the goal for this conversation from my side would be to cover as much as we can on prompt engineering and AI, Gen AI in general, from bottom up. So we'll build up from where maybe it started 2.5 years back and what developments happen in LLMs to the autonomous agents, which is the cool new thing right now happening. One thing I'll start with, I don't know everything. This is a very evolving space. Mostly everything I say now will become obsolete in 6 months time frame. But this will probably provide you a platform to just go deeper into what's happening, sort of dig deeper into the rat hole of Gen AI. That's where I am right now. We can start first by maybe a bit of simple prompts, right? Let's say, what is the capital of Telangana? I wanted to keep it very lightweight, so I'll just copy paste these prompts into ChatGPT in real time and let's see what it shows up. Let's start small. Yeah, I think yes. I'm guessing everybody is using ChatGPT on a day-to-day basis these days, so this is the first example that it came up with. Now, one simple thing that you may want to know here is that the LLMs were built not exactly for question answering. They were actually built for completions. So the base LLMs are tuned to complete a sentence. What that means is the cat sat on the table. So they will try to complete that based on the probability of how many times in their knowledge base they have seen that. But that was not very useful when OpenAI released it first. It was not as useful for humans because, okay, cool, it can complete a sentence. But if you look at Google used it in their inbox to complete the email that you're writing and so on. That's where it started. What OpenAI did differently is instead of looking at these base LLMs as completion engines, they instruction tuned it. So what instruction tuning means is you give a question and it gives an answer. So to a base LLM, if you give this question, what is the capital of Telangana? It can possibly add more questions like what is the capital of Telangana, what is the capital of Maharashtra, what is the capital of Rajasthan, instead of just giving you the answer. So they tune their model to question answer, and that's what really changed the dynamics of the entire LLM and the NLP industry today. So it gave the answer and so on. Now, it is smart and it is dumb at the same time. So let's try another example here. A 4-year-old or a 5-year-old can okay, so it finally gave the right answer. Often it doesn't. They are getting better as well. So what it ends up giving is either not or I, because it's not trained as such to count things. And you can ask many such questions. Let's say you can give it a mathematical problem and it might just fail at it because it's a completion engine at the end of the day. But what really helps in certain scenarios is to make the engine think. That's the first principle of prompt engineering. Give it time to think through things. What that means is if you simply combine this with this thing, so it will now show you about how it's proceeding about coming up with the fourth word. It would have been more magical if it said wrong thing first and the right thing second, which happened when I was preparing it. But this is how then it is thinking. So any problem that you give to the LLMs, if you say that let's think step by step, it works more often than not, because then it basically it's computing more power and then sort of coming up with the right answers. That's the basics that are there. These are few use cases you can look at. So you can prompt iteratively. So one simple thing is to ask a question, it gives you an answer. But we can keep building on top of that by combining multiple reasoning angles to it. So there's something I've put here. Yeah, so this is a prompt for it to help the marketing team create a product description. You are also saying that keep it 50 word only, you're giving the entire technical specification here, and so on. And we'll come up with this. I think we all have done that. But the iterative prompting, what that means is basically you'll compile together multiple things and then give it input. So step A, step B, step 3, step 4. 50 words, focus on a certain kind of outcome. For example, you want to create a description for a child. 50 word for a child in Hindi, and so on. So that's the iterative prompting that you can build on top of, which is the very first thing that you can start with. Then the summarization use case, I think, is one of the most common ones that has caught on, where you can just give a prompt. Is to generate again a summary of things, the review and summary. So now when it comes to a lot of e-commerce use cases, there are hundreds of reviews on a product that exists today. And you can simply say that give me one review compiling all of those and the sentiment of all of those. So all of that is now very easy. Earlier it used to be hard when you are training a machine learning model to detect sentiment, all of those things. Now because there is a general purpose model available, you just have to query it. When let's try the second one here. Yeah, so this was a review about a panda toy which a father gifted to a daughter on the birthday. Now we are basically talking about, instead of just summarizing it, your task is to also generate it for a particular department, for the shipping department, right? So you can simply say that, okay, now generate summary for the shipping department. Now imagine this review coming in for an organization which builds these toys. And then this review can be automatically categorized that, okay, what kind of feedback it is, for what department it is, and how it can be, which department should sort of look at this feedback. It sort of automatically says that feedback on shipping was timely, which means this is good. You can figure out more things on top of it. Earlier, which used to take a lot of time in annotating these texts, is now not required. If you can come up with this use case and then iteratively prompt the model on with these prompts. Like literally, this used to take a long time before. You take a text coming in, you do sentiment analysis, you do classification, modeling on top of it, and so on. Just a prompt.
What is the purple slash there?
That's just a new line, just to make it readable one after the other. Yeah. So the next one is inference. These are the most common use cases where you can use prompting for. What you are doing basically here is to infer the sentiment. So we're saying that, so this is the product review. Try to figure out whether the product review is positive or negative. So this is saying that needed a nice lamp for my bedroom and blah, blah, blah. I talked about the product review, whether it's positive or negative. So you're basically iteratively prompting it and also doing sentiment detection on top of it. I literally wrote a paper on this in my BTech. Just simple this thing. Now that paper is redundant because you can simply query a large language model on top of it. So all the parts of sarcasm detection and everything else are built into the large language model. The second part here was to now particularly detect the emotions out of a written statement, right? Whether, like, there are a lot of reviews coming in, a lot of people writing emails and so on and so forth. What are the things where a manager should get involved in supporting a use case, right? Or if a demo is done by the sales team, if it was not a good demo, a prospect writes a negative review and so on and so forth. So you want to detect the cases which are off. You can simply ask the model about that simple use cases. These are the things that used to take a long time before. This is a prompt. Basically, you're asking it to be an order bot, an automated service to collect order for the pizza. You first greet the customer, then collect the order, then ask for the pickup or delivery. You wait to collect the entire order, then summarize it, and then check the final time if the order, blah, blah. If it's delivery, ask for the address, finally collect the payment, and make sure to clarify all options like extras and so on. And this is where you have just given it the menu. A tool like this would take a long time earlier to be built because you will write each use case manually, not in natural language. Let's see how it performs. Yeah, how can I assist today? Okay, there is no pasta, so we'll go with maybe pizza. Let's go with cheese pizza. So one interesting thing here is that in the prompt you did not mention small, medium, large. It inferred it based on the 3 entries that were there, which used to be not the case before. Earlier code would do what you tell it to do, right? Which was very linear in thinking. This is very non-linear in its thinking. It is stochastic.
Should be intelligent to understand that 12.95 is the bigger.
Yeah. I mean, that was one thing I got surprised when I first ran this, that, okay, this is interesting. So let's say medium. So, I mean, then it ends up being a fun thing. You can keep playing around with it and so on. I've spent countless hours on this. Tomorrow at 12 p.m. The beauty of it is, like, you can keep changing your dynamics of things. Instead of, you can go back from here, say pickup to delivery. You can say that, no, I don't want pickup anymore. I want delivery. That was my mistake. And it will then pick up, go back and do that. For all of these things, earlier we would have written code that, okay, if the person goes back, do this and so on, because we were thinking linearly in a workflow. That's one of the things I realized, that earlier we created workflows and the code was there to follow the workflows. The biggest change that is happening now is that machine can create those workflows itself and automate it all by itself. There's a very good article on it which we can look at. So there are these data pipelines coming up. So Databricks, we all know that's like a big platform which can help you streamline data, both SQL and non-SQL data. Now from there, imagine you want to build an application where you can talk to a book. So that data becomes a book, right? Which is in the TXT format. Now, one thing which is becoming more and more important is the embeddings. Even OpenAI provides an embedding model. What it means is, you will, instead of the plain text, which could be a really huge, like the entire book is huge, you will create embeddings out of it. And now these embeddings you can directly transfer to the orchestration layer, or you can store it in vector databases. This is again a new kind of databases which are there to store the embeddings which are useful for large language models. So these are the different things that are happening right now. Now the orchestration layer is where the magic is happening. ChatGPT is one of the orchestration examples, right, of LLM. So LLM is at the base, ChatGPT is on top of it. What ChatGPT is simply doing is it is querying the LLM with the context in place without forgetting it. That's all ChatGPT is doing. So one of the orchestration is ChatGPT. But if you look at LangChain, which is the most common, if you may have used it, yeah, not LangChain. So what it allows engineers to do is to actually query the LLMs iteratively, so that you can have the chain of thoughts, or there's research coming up with the tree of thoughts. A lot is happening in the orchestration layer right now. Facebook came up with its own Llama index, which works on top of their own LLM called Llama, and so on. And then there is this playground where you can try a few examples. One definition-wise, if you want to know, so what we have been doing so far is called a zero-shot learning. What that means is you give a question and it has to give an answer. But you can do a few shot learning as well, where you give a question and some example answers as well to it for it to learn. So you're optimizing the answer that you want to get out of it. For example, if you have to solve mathematics and you give an algebra, you can actually give it some example that this is the possible ways you might want to solve it. And then it gets better and better with these few shots learning. Then comes the entire app hosting. So this is for the client side of things. LLM cache is coming up as well. MLOps is coming as a big domain you are validating. There's another thing which is not covered here is the monitoring, so that the right kind of data gets ingested into the LLMs. A lot of enterprises are scared about their PII data getting ingested into this black box, and it might show up somewhere else. So the firewalls is one thing that people are building, where they end up scrubbing the data and removing the PII, let's say credit card details of people from the data, and then not sending it to the entire LLM. So that's the architecture that is emerging. This is also changing very fast. LangChain became one of the fastest growing open source product. It's just out there, you can try it out. It's very simple to use. If I can use it, I think anybody can. Yeah, so that's on the architecture side of things.